Hi, Adesh. Good morning. Welcome on
Hey, good
board
morning to you.
for Work from
Thank
Home
you.
2021. Thanks for joining us. It's a pleasure to have you on board with us today to discuss about the security that has been built in at the core uh, in our Intel, right? So, Adesh, with attacks skyrocketing all over the place, right? We
Right.
see a lot of attacks from different levels. Earlier today, we also showcased a firmware level attack using Mosaic regressor that's been actually used by Chinese threat actors, predominantly for state attacks, kind of a stuff to attack other governments and so on and so forth. So, with attacks skyrocketing, what does security mean to Intel?
Yeah, so again, first of all, thank you for having me. It's great to be here on behalf of Intel and have a conversation with you and to share with you some of our capabilities that we have built in as a company into every product that we develop and have developed in the past few years and in the future that we will be developing as well. For Intel, we are focused on ensuring the security of our customers' computing environments, and we are committed to security in such a way that it has never been stronger within the company. In fact, we have got a group within the company that is focused on security at the silicon level, at the design phase, all the way through to ensuring the applications that are running on the servers when the process is designed and integrated by our vendors and OEMs, ensuring that the security is maintained at that level as well, because that's what customers want. Yep. That's what customers desire. And so we have, from our perspective, at the very foundation, we have an unwavering customer focus in everything that we do with respect to security. There is also a very continuous innovation in technology. I mean, as we all know, security is an evolving capability that has to be integrated inside the product. And you cannot say that my product is 100% secure. And so we have a continuous technology innovation process of bringing in the capabilities inside the hardware today as well as into the future. And then we are also building in and trying to build and aiming to have a very robust set of capabilities inside the hardware. If you go back to data center practices 10 years back, 20 years back, you needed to have additional attachments inside your server in order to give you that level of security. Today, what we are doing is we are mitigating most of the security attacks through the silicon itself by ensuring and having the capabilities built in the silicon for us. And so we are the only company in the world that has a security pledge where we have a clear focus on designing the products right from day one with security in mind. And it's not just with the designers, but it's with our manufacturing. It's with the team that is on the software side, the team that's working with the open source ecosystem as well. Everyone in the company has got this security mindset that has been built inside the organization. So for us, when you say what does security mean to Intel, it is in everything that we do, everything that we develop, design, and sell to our customers.
Wonderful, Adesh. Great. So people process technology embedded straight into every inch of Intel. Okay, great. Right, good. So Intel has been creating and innovating server-based technologies for a very long time, right?
Right.
In the heart of innovations, the computers and the server spectrum for a very long time. So how does Intel enable security at the core or at the foundation level?
So we actively work to deliver security without sacrificing performance. That is extremely important because many times questions are raised by customers and developers whether you are compromising performance at the core level or at the instruction level because you're adding in more security overhead. And our goal is to give you security without sacrificing performance. And so we work with our customers and industry partners where we can achieve levels of secure performance people expect and deliver the technology they trust. Our goal is to ensure a critical base of protection across the platform, focusing on identity and integrity. And Intel has a very long history of developing and delivering technology to help ensure the platform comes up correctly when it's booted up and it runs as expected. So our security engines, have been used over 1 billion times worldwide, right, across a range of implementations or hardware implementations by our OEMs and vendors. And our processors feature enhanced cryptography to accelerate performance and help secure, some of the transactions and secure transactions that are happening today in the world. And so some of the foundational capabilities that Intel has across its products, for example, is Intel crypto acceleration. We all know that cryptography is becoming an increasingly important element for data transfer, ensuring that data is transferred securely from point A to point B. And so having cryptography and algorithms that help secure the data while at rest or while at flight is extremely critical. So we have that capability built in. We have capabilities like advanced encryption standard, new instructions or AES-NI, that helps us execute the data, especially security algorithms, at a pace, at a speed that is much faster without compromising on the performance of regular applications or instructions running on the platform. We have foundational capabilities like BIOS guard and boot guard. We have a converged security and management engine, again, built in as well. In fact, we leverage a capability called platform firmware resilience that we have built inside a system. And this is a FPGA-based solution. So we have a FPGA-based solutions based on a Max-10 FPGA, which we have integrated inside our platform designs and reference architecture that helps us ensure that the firmware that is on the server is secure. And every time there is a access to the firmware, then that access is a secure access. And that level of capability is enabled through the Max-10 FPGA that we have built inside the reference architecture. We have, other foundation capabilities like platform trust technology. We have quick assist technology as well that helps us deliver a performance, especially for data in flight through the network ecosystem, through the network, ensuring that the performance is maintained at near-line speed while giving you that encryption and decryption that you want. So these are some of the foundational security capabilities that we have enabled in the platform today, and especially on our third generation Xeon Scalable Processor. But by no means this is complete, right? There are capabilities that we continue to see, continue to add. There are standards that continue to evolve from a security perspective that we constantly look at and bring into our platform, especially as the designs that we're looking into the future.
Great, Adesh. Thanks for sharing that multi-level, multi-layered security defenses that has been put in at the core or at the foundation. Yeah. You touched on the third generation Xeon Scalable process, Adesh. Could you share the key benefits of the processor and the security capabilities it delivers to the application developers and end users?
Yeah, that's a great question, Clement. This is, I love to talk about the new product that we have introduced, an amazing product codenamed Ice Lake. And we call it the third generation Xeon Scalable Processor. And the product was announced in April this year with some amazing capabilities from a performance perspective, plus from a security perspective that have been built in. So we have developed a balanced architecture with built-in acceleration. Again, very important to understand, it's built-in acceleration and advanced security capabilities at the silicon level itself for the most demanding workload environments. And, we haven't done this alone, right? It's with a partnership with some of the world's software leaders and solution providers. And so the third generation Xeon Scalable processors are optimized for different workload types at different performance levels all ensuring that there is an open architecture that our customers and our software developers can use, and they have been known to use and trust for decades. And so some of the capabilities that we have built in, and I alluded to some of them before, let me talk a little more into some of the, a little more depth into some of the capabilities. For example, the software guard extensions, or SGX. And this is again a unique capability that it's not new to Intel. We have been having this for a few years, but on our mainstream dual socket platform, this is the first time that we have introduced it. And so it provides a fine grain of data protection via application isolation in memory, right? Independent of the operating system or the hardware configuration. This is extremely important because, when you are, let me take an example of a virtualized environment. When you're running a VM and you have your application running in a virtualized environment, you want to ensure that your virtual environment is secure. And you want to ensure that if for some reason you move your VM from one system to another system and you do what's called as a, let's say, live migration, then you don't want anything to be broken and you want to ensure that the migration is secure. And so with software guard extensions, you can build enclaves, memory enclaves for your application running in a virtualized environment and ensure that the data migration is smooth and it is completely secure. That's one example of how SGX really helps. We also have crypto acceleration. I talked about it before, and it is, again, it works in conjunction with our AES-NI, which is a built-in vector set of instructions that helps us ensure that the data is encrypted and decrypted, especially when you have got your application developers who want to make use of encryption and decryption capabilities. We have those instructions built inside the Ice Lake processor architecture. So security hash algorithm extensions, for example, or unique RSA or DH encryption protocols that our developers want to use, we have those capabilities now. Some of the instruction level capabilities built inside the processor, which means that when you call those instructions from a developer's perspective, your execution time is significantly reduced because you don't have to create your own code for developing those algorithms. We have them capabilities already built inside the processor. All you need to do is to make a processor call.
Great.
We have total memory encryption. Again, a capability that is very unique to the Ice Lake processor family. And I talked about our platform firmware resilience in conjunction with our FPGA Max 10 that is built inside the reference architecture that helps ensure that your firmware, which by the way is extremely critical, that every time the server boots up, you want to ensure that it boots up in a known good firmware configuration.
Correct.
And for some reason, you have a malware or you have an attack on the firmware, the PFR or the platform firmware resilience capability on the system helps ensure not only to block that malware, but if for some reason it gets corrupted, it is able to automatically boot from a known good configuration.
Great.
So you have got fallback mechanisms that have been built inside the platform to make sure your platform comes up, in a secure environment.
Great. Wonderful, Adesh. Thanks a lot for sharing so much about how Intel is actually taking, and I've taken for years, security serious, and you've put in tons and tons of layers and new technologies, and we are very happy to hear all about the Ice Lake processor, your third generation Xeon Scalable Processor. Adesh, thanks a lot. Thanks for being with us. It was a pleasure having you on board, right? Have a great day. Stay safe. Thank you.
Thank you. Thank you for having me and have a great event. Thank you so much, guys.
Thanks, Adesh. Thank you.